Okay, so looking at our first one here, we're writing a function rule. Just means, so if you want, you could just circle this and think equation. That's all we're doing there. So writing an equation to get from x to f of x. In other words, what am I doing to x? If I start at x, what am I doing to get to f of x? So try a few things. Try multiplying, try adding, try subtracting. So how do I get from 0 to 10? Yeah. Add 10. Does that work for 1 to 11? Yeah. Does that work for 2 to 12?
Yep.
3 to 13? Yeah. So that works. So it's just plus 10. Okay. Equals f of x. So our equation for this one, we could just write it down. Number 1, maybe put it down here. Give yourself some room. F of x equals x plus 10. Now I'm going to say give yourself some room there because when you get down to 9 through 14, it tells you to evaluate. So number 9 says evaluate f of 5 for exercise 1. So we're going to need some room. So maybe making a grid down here where you have some room. Okay, that way you can go ahead and finish that up. All right, so I want you to work on that. Oops, you didn't see that. But I want you to work on trying to write a function rule for each of those. Okay, try adding. If it works for the first one, try it for the second one. Then try multiplying. Works for the first, try it for the next, and so on. Okay, you can work with your partner if you want. What did you guys get for number 2? F of x equals what? Yeah, what do you got? 5x. 5 times x. So 5 times 0 is 0. Good. Okay, number 3, f of x equals, good, Annalise? X squared. Good. X times x, or x squared. Yeah, if you multiply x by itself. Number 4, f of x equals, someone new? Caden?
Add 3.
What's that?
Add 3.
Add 3, so x plus 3. Now how many got those 4? Good. Okay, so different things to try. Here's what I want to do right now. On those 4, I want you to take number 9, 10, 11. Notice 9 says find f of 5 for number 1. So using this equation, or this function right here, I want you to find f of 5. Number 10, find f of 8 for exercise 2. Do that for the first 4. Okay? So do 9 through 12 in those areas there. Do what you think you should. It's going to be part of your quiz tomorrow. Given that input, find the output. So the confusing piece sometimes is knowing where that 5 goes. The 5 has replaced the x, so f of 5 is equal to 5 plus 10. In other words, we're just solving this side. We don't worry about the f of 5 side. This whole part we just kind of ignore now. 5 plus 10 is 15. So when our input is 5, that's what that says, our output is 15. Okay, f of 5 equals 15. So when x is 5, y is 15. That's all that says there. Okay, so go ahead and do 2, 3, and 4. All right, I'm going to go ahead and get your answers up here. So number 10 says find f of 8 for exercise 2. So that's 5 times 8, or 40. And you can just leave it like that. You don't always have to put it in the ordered pair format. Okay. Number 11 says find f of 6. So that's 6 squared, or 36. And then number 12 says find f of negative 1. So that's negative 1 plus 3, or 2. Okay. Any questions on those? Everyone rate themselves 1 to 5. Kind of a piece hopefully we're okay with. Okay? Well, number 5. Well, first of all, I guess on 5, 6, 7, 8, are any of these something different other than addition or multiplication? No, they're all addition, multiplication. Like number 5, what are we doing to f of that, or to x? Go ahead, Annalise. multiplying by 2. Yeah, so 2x. Okay, everyone tell your neighbor what you're doing on number 6. All right, Toki, what are we doing there? Yeah, number 6, we're adding 2 each time. So it's x plus 2. Okay. Number 7, go ahead and tell your neighbor what you're doing on number 7 there.
-1.
Okay, so are we adding on that one?
No.
No, what are we doing?
Subtracting.
Subtracting. So we're subtracting 1 each time. So x minus 1. I guess it's the same thing as adding -1. So you could make an argument you're adding a negative. But okay. Number 8. Go ahead and tell your neighbor what you're doing on that one.
Multiply by 3.
All right. Jake Burley, what are we doing on that one? Going from x to f of x on number 8? I knew it. That's why I called on you.
Yeah, got that. It was multiplying by 3.
Yeah, I think it's just multiplying by 3. 3x. Good. Okay. All right, I'm not going to do the last part where we're plugging in here for 13 and 14, but I think you guys can get them. Okay. I'm going to go ahead and set that aside. Use that to help prepare for your quiz tonight. That's part of your pre-quiz. Our pre-quiz has kind of 3 different parts to it today. All right? That's part 1. Part 2 talks about our review of relations and functions. So on this, taking a look at this sheet, this is actually a picture of Mr. Vogel's whiteboard back when we wrote this stuff up there. You can see like his beads. He likes his little beads. Yeah. But anyway, we wrote this on his board a long time ago. So, but right here, I want you to tell which are just only relations and which of these relations are functions. Okay? You can either write maybe an F for the ones that are functions and an R for the ones that are just relations. Okay? You work with your partner on it. Discuss it. Should be a review. Here you go. A couple of you have asked, is this a point? Yep. And this is a point as well. It's tougher to see. All right. So there you go. Okay. So on letter G, that's a point and that's a point. Okay. Since most of you are done, let's check it out. Letter A, everyone, function or relation?
Relation.
It's only a relation, right? Because of what x value causes that? 5. 5 goes to both 2 and a 3, and that can't be possible. Same x can't go to 2 different y's. Okay, number 4, relation or function?
Relation.
Yeah, it's a relation. We have the same x going to a lot of different y's. That's not good. Okay, so we got relation. Number 3, relation or function?
Function.
Oh yeah, this one's tough. Does x repeat? Yeah, it does. 3 goes to 3, and 3 goes to? 3. Well, it's okay if it goes to the same number, because how many points is that going to give you on a graph? It's going to give you a single point at 3, 3. So this is actually a function. Tried to trick you there. Yeah. Some of you couldn't trick. A lot of you were asking about it. How about this one? Relation or function? Function. X doesn't even repeat itself, so it's automatically a function. So you should always see if x repeats. If x repeats, then see if it goes to a different y. Okay, if it doesn't go to a different y, it's a function. If it does, it's a relation. Okay, letter E, what type of test are we running? Vertical line test. Relation or function? This is a function because as we run our vertical line through here, it only hits the graph in one spot at a time. Okay, letter F, relation or function? Relation. It hits the graph in multiple spots. And letter G, relation or function? Relation. The big problem's right here where it hits that point and that point. This is a relation. Okay, any questions on those 7? How many have all 7? Or 6 of 7? Some of you missed letter C. It's okay. Okay, letter H. Does X repeat? Nope. Then that's a function. Does X repeat? Well, it does. We don't see it multiple times. So how do we know it repeats? Annalie? Yeah, because this little x right here has 2 arrows going out. It has an arrow going to 0 and an arrow going to 8. This is a relation. 3 goes to 0 and 3 goes to 8. That would be like having the ordered pair 3, 0 and the ordered pair 3, 8. Okay? We can't have the same x going to two different y's. Okay? How about J?
Function.
How many say function? Relation? It is a function. You can have the same or different x's going to the same y. That's okay. That gives you a horizontal line when you graph it. Okay. Any questions on that page? He's doing a good job. Let's go ahead and turn the page over. Have some graphing that we'll have tomorrow. Okay. Now I want to take a look at number 1 together. Okay. I want you to put your rule right here to fill out your table. Go ahead and write what your rule is. Okay. What is our rule? Someone that hasn't volunteered today? Yes, Marie. Yeah, it's x minus 6. Okay, so when I'm filling in my table now, you don't need to put the f of x. You just put the other piece there. You put that x minus 6. When I'm filling in my table, the thing that's going to change is the x. Everything else stays the same. So I'm just putting parentheses where the x was. Minus 6. It's a really boring way to do that. Yeah?
Do you have to put parentheses?
Do you have to put parentheses? You don't have to. It won't always make a difference in your problem. However, it'll save you from mistakes later on. Okay, so I'm trying to set you up for success. So like down here on number 3, if you don't put parentheses, there's a chance you make a big mistake. Okay? All right. So in here, what values of x should we pick? Well, that's up to you, as long as it falls on the x number line here. So I wouldn't like pick 100 because you don't see 100 on the x-axis. So what's the easiest value of x?
0.
0, yeah. And so I might go on, I might put 0 in the middle and extend out from there. That's what I personally like to do. Maybe count like that. And that gives me a pretty good deal. So that's -3, -2, -1, 0, 1, 2, 3. You don't have to, but I personally like 0 because it's easy to do the math. 0 minus 6, -6. And that gives me the ordered pair, 0, -6. Okay, so let's go ahead and finish up that table and then plot those points, please. Some of you will start noticing that there's a pattern that happens. Right? And many of you will start seeing the trend. If I would actually continue the trend, I would have been a little closer to the line there. Fell off the line. There we go. All right. So on this page, I want you to go ahead and finish these graphs here. Okay? The next 3 graphs. Spend about the next 10 minutes on them there. Make sure you get... Okay, as I was walking around, I saw many of you have your rules in here for this. 1/2 x plus 2. I was even checking out a couple papers and saw that you guys had actually put your parentheses in like this first, which is great. You're just replacing that x value with a number, but everything else, the plus 2, stays the same. So the only thing that changes in that whole rule is the x. So this piece right here where x is, that's where we're putting our number. That's our input. So what should I go up by on this one? I could start at 0 again if I want. This is one of those ones where we have a fraction on the bottom, or we have a fraction here. We have a 1/2. Remember, the easy way to deal with that, if you want to come up with whole numbers for your y value, what should you count by? Kyla? Yeah, 2's in this case, because the denominator is 2. Okay, so 2, 4, 6, -2, -4, -6. Now, if you didn't count by 2's and you went up by 1's, that's okay. It just means you're going to get some half numbers over here, right? So, but if I'm putting in like -6 here and I do 1/2 of -6, that's -3, plus 2 is -1. If I go 1/2 of -4, that's -2, plus 2 is 0. And eventually, when you do these, -1 plus 2 is 1. You start seeing the pattern over here. You can say, in linear equations, that's how that works. So you'll see that this is increasing by how much every time? Yeah, 1, right? So we could guess that this next number is going to be 2. If we put our 0 in there, 1/2 of 0 is 0, plus 2 is 2. And 3, yep, that works. That's 1 plus 2 is, okay, and then you get 2 plus 2, and 3, or excuse me, that's a 6. But that becomes 3 plus 2 is our 5 there. Okay, so I'm going to start plotting those points. Now, what type of line should this give us? Or what type of graph? I guess I kind of gave it away, huh? Yeah, this is linear, right? Good, this is linear. Okay, we know it because x is to the first power on these. And then once we graph them, we should see that straight line. If I actually use a ruler. There we go. Okay. All right. Looks like most of you had a pretty good start here. So we've got our rule as x squared. Okay, this is really important. You put parentheses on this one. So x becomes our parentheses. So the only thing that isn't in parentheses is the squared. All right. You can go ahead and pick some values. I'm still going to pick 0 again. In fact, that's my vertex here. 1, 2, 3, -1, -2, -3. So those of you who use calculators for this, even though I know you know what 3 times 3 is, but this is -3 squared. And when you use calculators, you better put parentheses around it. Otherwise, your calculator is going to spit out an answer of -9. The actual answer is -3 times -3, or negative times negative is positive. Negative times negative is positive. Negative times negative, positive. And with a quadratic, and we know this is quadratic because of the x squared, what type of graph should it be? That should be a 2. What's our picture look like on a quadratic? Yeah, Cole? Yeah, parabola. Okay, good. We've got our parabola. 1, 1. Okay, 2, 4. And 3, 9. make sure your parabola looks like on the bottom here, make sure there's actually a U shape, not a V. It doesn't come down to a single point. It shouldn't be pointy at the bottom. It should be like a cup at the bottom. Okay. All right. How many got that one? How many had really good parabolas? I was impressed walking around looking at like just the shape of them. They're not easy to draw. Some students make tough ones there. Okay, this last one right here, our rule is this. Now tell your neighbor what that graph is going to look like. Now, what's that graph going to look like and why? Okay, volunteer, what's the graph going to look like? Keegan, thank you. Yes, raising the pit. All right.
Oh.
Go ahead.
It's gonna be a V shape.
V shape. How do you know?
That's what Ryan just told me.
Because Ryan told you. Okay, good. So Ryan, how do you know? He threw you under the bus. Can you believe a friend would do that?
I didn't say that though.
Oh, okay.
Yeah, you did.
I said maybe a slide.
Maybe a slide? Not a slide. It is a V shape. Keegan's correct. Hayden, why is it a V?
Because there's the X is inside the absolute value.
X is inside the absolute value. You guys need to know that for your quiz tomorrow. I'm going to give you a pre-quiz as your homework tonight, and you really want to do that. Make sure you have good explanation. That's going to be a good chunk of your quiz. But X is inside the absolute value, so it should be a V shape. That's what it should look like. So when you're done here, that would be your quick check. But as I'm setting this up, there's what we've got. Okay, we put in our parentheses. I realize that some of you are done with this one. I realize that some of you are just starting it. I can give you a little time, but if you're done with it, you should be working on that CBA repair. I want to get that taken care of prior to you walking out today. And some of you, it's as easy as just explaining one little thing you did wrong. We're still going to have your vertex on this one. To those of you who've done this one, your vertex needs to be at, anyone find the turning point? How many just got a straight line on this one? Yeah, dude. Our turning point actually needs to be at -5. It's what makes this thing inside here looks like become 0. So X would have to be -5 to make that a 0. So I'm going to put that -5, which means -6, -4, -3, -2, and this is -6, -7, -8. That's our turning point. So we don't change these negatives to positive until after we do math. Okay, what I mean by that is -8 plus 5 is -3, and then the absolute value of -3 is 3. -7 plus 5 is -2. The absolute value of -2 is 2. -1, absolute value of -1 is 1. 0. And then you'll see it starts repeating itself again. And there is our V shape. Okay. I'll be walking around answering questions.